you have to put in full mode, okay? And Asim works at IBM Watson Research Center, and his talk will be on small language models for enterprise agentic workflows. Asim, it's yours.
Thank you. I hope you can hear me.
Yes, very well.
Okay, great. So first of all, sorry I was not there in person, so for some personal reasons. So I'll be talking about small language model enterprise agentic flow. Everyone is talking about agents since early 2025, especially, and it will go on for some time and with a lot of reasons. So we can see agents are everywhere in all the industries. Their impact surface is increasing. What makes good agents, we also understand very well. First of all, integration with tools, memory, long horizon planning, reasoning, all the things that we would like large language models to be good at. And then so once we have good agents, we can worry about some other things that I will talk about. For example, cost. Okay, so cost is one of the major factor in deciding whether we go with larger models or smaller models. So I'll be talking about that later. So why is scaling breaks in enterprise agents? So we saw initially that large language models got some early wins where we just waited and for the next big update in the LLM, and suddenly the benchmark started to improve. But that cycle have almost stopped right now. Like even if someone says that we have better numbers on some tasks, on reasoning and something, it does not make so much sense because it does not improve the enterprise workflows. It does not improve enterprise benchmarks. It just improves the benchmarks that are there in open because of the kind of data being used. So so that is why like the scaling first mindset work for demos but not for agents. We need real architecture, not just big models to make the agents work. Um, and just two terminologies like agent and agentic workflows are used interchangeably, kind of. In just my mind, agent is more like any model that interacts with external environment. Agentic workflow is much more. Agentic workflow can involve, for example, a workflow kind of thing. It can involve policy guardrails, approval, human in the loop, monitoring, memory, so all that. So agentic workflow is what is getting more traction, at least for enterprise use cases. In simple agent, which I show on the left hand side, we just have large language model. We leave everything to the large language model, which can be very expensive also, and it cannot be like very explainable, because there are no many symbolic tools involved in that. And this is a kind of like an actual agent that we are running. We created an SRE agent, which is a site reliability engineering diagnosis agent. So we can see already that the prompts get very long. It gets very complex. So even if you're using a bigger model, then you can prompt, you can like prompt tune the model to some extent, but not like very successfully. You can change the big model, like the even the frontier model, and suddenly your performance will take a hit. So with this kind of complex, and this is not the most complex system prompt that we deal with, there are much more longer ones. So how do we break down the problem, and how do we use smaller models to solve the problem? That is what I'll be talking about. Okay. So, limitations and related work. So, let me go briefly over what others are thinking about this. What makes good agent? I'll talk about some other work that you can refer to. So, so I'll be covering few topics like reasoning, planning, tool action, There are others also that are required, but I'll not be able to focus due to time limitations. And the question goes back to, can large language models even reason? And small language model, when I say small language model, they're particularly weak at reasoning. So why do we even consider them for agentic workflows? Um, one of the issue that we face with large language models also is that whether they are doing real reasoning or they are just showing to reason. Okay, for example, style is not equal to correctness. So if the style is very good, if the language is very fluent, it does not mean that the large language model is doing a very good job at reasoning. Sometimes also large language model reason very well, but in the end the answer is wrong. Okay, or the reasoning is wrong and the answer is correct. Okay, so all these things here. So these are the caveats, and why reasoning is so important. Why we it's For example, other tasks that large language models do, like text summarization and stuff, they can be suboptimal, but when it comes to reasoning, we don't want them to be suboptimal. So it's just like having a calculator that works 80% of the time, right? So it's useless to have a calculator that works 80% of the time. And similarly, if I say that I have a calculator 2.0 that works 95% of the time, it's still equally useless, right? So we want this part, reasoning and planning part, to be very good, or we break it down into workflow. Okay, we don't rely on small language models alone to do the heavy task of reasoning, or we loop around with reflection or some mechanism. And a proof that we can have is that even large language models are affected by noise, kind of noise in the data. We saw in GSM 8K, like the models, frontier models have also already saturated the benchmark. But GSM no ops is a data set where they added a plausible but irrelevant sentence in the GSM 8K arithmetic math problem, and suddenly the performance take a hit. Like even the best models, frontier models out there, their performance decreased significantly. Phi 3, for example, is a very good reasoning model that came last year, but you can see that the performance is like minus 62% drop in the performance. So we can already see the problem with reasoning and planning beyond a certain capability. Okay. These are some other issues that we saw with AI agents. So for AI, I like this one most. AI agent wiped companies' code base. So there is no magic going on. We are leaving things to large language models. So there should be all the guardrails, all the permission, everything around for AI agents to work properly. Okay. So this is a very drastic thing that AI agents can do. So coming to the money spent. So money spent, you must have seen using Claude Code, using like agentic workflow. So even a single query to agents can sometimes cost tens of dollars. I have seen even one query costing more than $100. So they, when as the contexts keep becoming longer and longer, and we get feedback from tools, we get observation, we keep appending everything naively, and we keep giving it back to the large language model to process it. It just creates huge token count for input and also the output that we want, and it costs a lot of money. Okay. So especially with agents, you have many repeated reasoning loops, you have multi-step tool interaction, and then you have correction cycles, which cost a lot of money. So saying that I created a very good agent, just hook your Claude with it, does not make too much sense. It's not practical in many enterprise applications also. Let me skip this. So this is a good paper. This is a position paper by NVIDIA. So NVIDIA is also one of the companies that talk about small language models. This is one of the position paper where they claim that small um, models are much better uh, for agentic workflow compared to larger models. And the reason is that small language models know their limitations. Small language models can call large language models when they are not certain, but it's easy for small language model to say I don't know compared to large language model. And similarly, they also promote modular designs, which we are also working on. Another paper by them is a tool orchestra paper, where they train a central orchestrator, which become kind of a reasoner and planner, and the orchestrator have access to large language models. So whenever they are not able to, when the small model is not able to solve something on its own, it calls the larger model to help it. So this is another very interesting approach where you can train with reinforcement learning a small model to be much better at reasoning with help of large language model whenever it needs it. So my team is focused on these three areas. One is activated LoRa, generative programming, and tool calling as an agent. Uh, Activated LoRa is a technology that we have already put in Hugging Face PEFT library, so you can directly use it there. Um, so the idea is that whenever we have smaller models, we usually don't train the full model, we just train a LoRa adapter on top of it. So if let's suppose we want to teach a model to reason, teach a model for tool calling, teach a model for let's suppose reflection, we just train LoRa adapters. They are very easy to handle because of like low memory requirements. And in the end, when we load it, we just load one single base model and multiple LoRa's. We get huge memory savings out of it. But when it comes to inference time, we have to compute KV cache for each LoRa adapter separately. So this is what happens in general cases. So we pre-fill the KV cache and then we generate the answer. And if we need to change the LoRa adapter, we again pre-fill the cache, we pre-fill for the generated answer also, and then we generate the answer that we need. When we switch again to LoRa 2, we again have to do the same process. So this pre-filling of KV cache is very expensive process, and this makes the inference very slow. So we have a technology called activated LoRa, where we just pre-fill once, we generate the answer, and then we keep switching LoRa's um, without recomputing KV cache, which makes it very fast. So this gives us an opportunity to have many different adapters and just keep switching between them very efficiently at inference time to generate the answer. And this is, so as I said, activated LoRa is already on Hugging Face, PEFT. This is a Melia library, which is also available in open source. This helps break down very complex system prompts into very organized and structural prompts and structural programs, I should say. So, for example, you can break the instruction part of the system prompt, validation part, or and repair part of the system prompt into separate parts. You can do some of the tasks symbolically. You can, for example, counting the number of lines in your answer should not be left to large language model. We can have symbolic solver for a symbolic tool for that, right? So Melia helps with that kind of stuff. It really helps break very complex system prompt into very structured programs. So this is another thing. And the thing I'll spend a little bit more time is tool calling as an agent. So here what we are doing is that we break down. So usually what happens is for tool calling, we just ask a model and it sends us the tools back. Okay. But there are limitations to that